So let's get started. So hi, I'm Sven. As Lynn introduced me, I'm one of the founders of the Istio project. But I'm actually not here really to talk about Istio at all. I'm here to talk about how we at Google rolled out Sidecars now about 6-7 years ago to all of Google when there used to be no Sidecar, and sort of the lessons we learned along the way and how we managed that. And so before Istio, actually, that was my job. I was the lead of the team that built the Sidecar for Google and rolled it out, and several pieces of functionality in that. So, and we tried to do it without breaking anything, and that's actually kind of the key thing. So the first thing I want to talk about is actually why a Sidecar. And so this was covered actually in a few talks today around sort of why service mesh, but there are actually reasons that we adopted it that aren't really quite related to service mesh, although they're a little bit. But one of the main reasons is just around language neutrality and how many different languages you have. So at the time that we were doing this, Google had 3 production languages, basically. We had Java, C++, and Python. And along came Golang, this new upcoming language that was being developed at Google. And Google at the time had lots and lots and lots of per language stuff. So we had HTTP and RPC client libraries and server libraries. We had a bunch of service management. So all the stuff in service mesh, back in the days before you had a proxy, you did all that in code, right? So we had libraries that did all the observability, all the sort of precursors to tracing. We were doing that at Google on a project called Dapper, right? We had the precursor to gRPC and Stubby. We had all this stuff in there, and it was doing all those things that service meshes give you, just in code. And the people building Golang, it was actually a pretty small team, and they're like, we don't want to rewrite all that stuff, right? We don't want to build everything out. We also had a bunch of API management. Actually, that was another of my jobs. I was one of the leads on a couple of different API management projects at Google, and we were sort of switching away from a central proxy model to a distributed model. And again, we didn't want to write this in every language, so we were like, we're just going to write it in C++, make it super fast, and run it as a sidecar. And of course, there's a bunch of other stuff, right? So you, at any big organization, you have lots and lots of different client libraries. So we had storage libraries for Bigtable. That thing was gigantic. And it had to be written in a bunch of different languages, right? This just gets painful. So it's really nice if you don't have to write that in every single language. And one of the other problems with having all these different languages is that they start to diverge. You get problems where the defaults are different in different languages. You have different bugs in different languages, and you have these weird interactions where Java on this version with this setting talking to C++ on this version with this setting, that breaks in some weird way that no one actually understands why, right? And it takes a long time to debug. It's much, much nicer if you have that all in one place. And then, of course, also you have to do performance tuning now on X number of languages. And again, looking at Go, small team, even at Google, it's like, no, we don't want to do that. So they actually were the team that sort of originated the idea of a sidecar, and then we took it over from them. There's some other actual problems that aren't quite related to the language issue as well. And actually, this was maybe even more important. The language issue you can kind of throw money at, right? You can just spin up more and more teams that are building these systems in every language. But when you have a huge company with a huge number of different processes running, and you have, let's say, a bug in the TLS library that needs to get rolled out to 1 million different processes and upgraded, and by the way, it's a 0-day, and so you need to upgrade it like in 2 days a week, this is really, really challenging, right? You have to contact 10,000 engineers, 20,000 engineers and tell them, okay, everyone you need to, if you were between this version and this version, you need to update and do a rollout, and you need to rebuild, requalify, right? Roll out the fix. I hope you have a branch of your current rollout because maybe your head is somewhere new, right? You have to do all this stuff, and it gets really, really painful if this is critical. So, for the language reasons and for the update reasons, we're like, okay, we have to have a sidecar. Or we have to have something, right? It doesn't have to be a sidecar, right? There's other options for getting this functionality into places. And we actually looked at a bunch of these and rejected them. So we looked at something like Swig, a foreign function interface. There are various reasons that didn't work out very well. One of them is actually it doesn't help the update problem. So it sort of got like removed from that. It helps with the language thing, but then you still need to update these. DLLs we looked at as well, and actually we spent a lot of time investigating DLLs. The way we had designed our systems, DLLs were kind of horrible. So everything is statically linked. Now if you wanted to switch to DLLs, you had to like rewrite all of Google's software to support that, and that was not going to happen. And then the other thing we rejected, but actually it's not really rejected, is, okay, can all this stuff be remote services? And in some cases, the answer was actually yes. Some of the stuff that was in a client, you could actually move to remote service, and where we could, we did that. So if you look at like Cloud Bigtable, Cloud Spanner, services from Google, those don't actually have these giant 100 megabyte client libraries, because that would be horrible. So even though the internal versions had these big libraries, we figured out ways to make the systems better, do it all through remote service, and where you can, you should do that, right? You shouldn't actually run stuff in the client if you can avoid it. But there's some stuff that you just can't do that, right? So your tracing library or your TLS library, right? Those things mostly can't be run as a service. Actually, some bits of it even can. So like TLS Handshake, we actually developed a model where it's not actually a remote service, it's a service on the same node, but actually you can do the handshake through a node, and then you don't have to run that thing locally. So there's little tricks you can do to try and remove as much as you can. Okay, so we had the sidecar, we built it in C++, we spent a long time developing it, and then we had this problem of, okay, we have these millions of processes running without a sidecar, and how do we actually get it out? So this is sort of, the rest of this talk is kind of an in-depth view of what the Pinterest talk was talking about at the end there, about like, how do you actually roll things out? How do you deal with this problem? So we decided, yes, all right, we will take that challenge, we will do it. So this is actually really, really scary, right? Especially if you have a bunch of critical services that you do not want to break. Search, ads, Gmail, right? These kind of big, scary systems that are serving millions, billions of users. You don't want to break those. You want to make sure this is safe. So one of the things we did is actually say, okay, we're not going to start with any of those things, right? We're going to start with small people that have something to gain from this, right? The people with the most to gain. So if they were getting some functionality that they couldn't get elsewhere. So that was actually the best possible customer, because then they actually had incentive to work with us. So there were two big ones here. One was Golang, as I mentioned before, right? That was a big driver of this. And so any of these new services at Google that were being written in Golang, right, they needed access to Bigtable or Spanner or whatever it was. And so they got sent our way. We set them up, we developed the system, and got them to be able to use it. And so they'd be early testers of this stuff. The other big one, and the one I was directly involved in, also was the API management part, right? So we built this out. People wanted to try out the new generation of API management that was 100x faster than the previous generation. The only way they got it is by adopting this sidecar. So we made it win-win. The next thing you want to do is make it as fast and cheap as possible, right? So when you look at this problem of rolling out sidecars, a couple of people have talked about this, right? The main downside to service meshes is the latency, right? The latency and the resource usage, actually. There's two. So you're going to be introducing a proxy on both the client and server side of every connection. That proxy is going to take CPU. It's going to take memory, right? If you use disk, it's going to use disk. And it's also going to cost you latency. And for some services, that's actually really, really painful. So we actually spent a lot of time investing in performance. The performance of Google's internal sidecar is actually orders of magnitude faster than any of the ones you can get externally. We're actually working on changing some of that right now. So we're trying to help invest in things like Istio and Envoy and make those sidecars as fast as our internal one, because we want to use it too. But you really have to spend the time, right? It takes years and years of effort to make these things as fast as they possibly can be. Because it ends up being a huge savings, right? If you're talking about millions, more than millions, billions of requests per second, let's say, and you talk about the latency of each hop being, 5 milliseconds or something, that's actually very, very material and very, very costly. So something else we did to actually help out is to identify people that would be affected by this. So if someone is actually going to be affected by the fact that you're adding this proxy, or you're adding the sidecar and you're introducing resource usage, right? If they're close to their limit, you need to let them know. And so we were very proactive about reaching out. One benefit we had is actually most of most of our systems were actually starting to move to this autopilot mode where they would actually get the resource usage adjusted automatically. And so for them, we didn't have to worry about it, and we could filter them out and only look at the people that were sort of statically set up. Reach out to them and say, hey, we're going to introduce this thing, try it out, make sure it doesn't break you. If it does break you, add resources. The next thing you want to do, of course, is actually sort of with that proactive reaching out is warn everybody, not just the people close, but like let everyone know this is coming. Let them know as you're doing it, and let them know while it's happening, and let them know when it's done, right? Like just keep warning them and let them know, yes, we are changing this on you. This thing's coming, it's here, it's happened, and make sure they know what to do. And of course, when you're doing this, you want to take it really, really slow. So if you're rolling something like this out, you're rolling out a sidecar to millions of processes, you don't want to do it overnight, you want to take your time. In our case, it took a year and a half, I think, to complete the full rollout. But you want to take, hopefully not quite as long as that, but you want to take your time. You want to go slow. In our case, we did sort of cluster by cluster, job by job, right? Even start with like one task in a job, make sure it's safe, and then continue the rollout. And the other thing you want to do is actually, if you do break someone, you want to make sure that opt-out is really, really easy, and I'm just going to talk a little bit about that later. So you've rolled it out, you've got this sidecar now in your millions of processes, but one of the key benefits of this thing was that we could do updates, right? That we can like find a security vulnerability, or someone else tell us about one, and like go fix it, and roll it out to millions of sidecars and not break anything, right? So upgrading actually is really scary as well. We had a bunch of different approaches we took here. I'm going to go through a couple of them. So one of the main things we did is actually split into a dev and stable branch. Dev we did weekly, stable we did monthly. And this helped us let people try things out early, right? So if someone was actually worried, if someone was critical, they could try out dev, give us feedback early, make sure it didn't break. And then we roll out stable. The other thing we actually made, and I'll talk about this a little bit later too, is we made testing really easy. And so one of the things you could do is you could have your tests against dev, or have a different set of tests, one against dev, one against stable, and then get that early feedback, right? It's all about getting early feedback on any changes. You also want to make sure this is as simple as possible. You want to make it automatic, not manual. So for most of our users, they were on automatic, right? They got the latest and greatest sidecar on a restart. And I'll talk a little bit more actually later about why we did restarts, but we wanted to make sure that most people just get the latest. There are people for whom that does not work. So they actually care a lot about exactly which version. There are some teams at Google where there are no changes allowed basically at all automatic. Everything has to go through code review. Everything has to be very, very, very securely locked down. For them, we came up with a different mode, which was what we call bound. So the bound mode is basically you get the version that was the latest when you built your binary. So you build a binary, the latest is version 10. That version stays with that binary as long as that binary is out there, and as long as that version is still supported. And so we had a contract with these teams that said, hey, okay, if you're in this mode, you better be doing updates pretty often. All of them were like weekly, so this wasn't a problem. And they need to be taking critical fixes quickly. So there was a small list, right? There was like maybe 10 teams out of the thousands, right? So 10 teams were allowed to run in this mode where they are bound to the version, they get it, they get control. They have the say, everyone else is on autopilot. And even with updates, you don't want to take it a year and a half to do an update, but you still want to take it slow, right? So you want to make sure you're qualifying with that dev track, a canary track, whatever you do, make sure you're qualifying these releases with early users, getting things in their canary clusters, and then slowly doing that ramp up to 100%, right? As the folks from Pinterest were talking about, right, you can do like a specific host, right? You want to do things slowly. You want to take your time. And you also want to make sure you don't make them grumpy. You don't want to make your user sad. So this is what I was alluding to before about rollback. So one thing we realized very early on is we could not be responsible for rolling everyone back, right? So if something breaks, that team, right, the SRE team responsible for that needs a very, very quick button that says, this broke me, fix it. That doesn't actually roll it back for everybody, because there was bound to be problems that only happen to one or two users, right? You change one little thing in one library, and a specific user with a specific setting and a specific circumstance hits the bug and everyone else is fine, right? That user needs a way to roll back. You don't want to roll the whole thing back, especially if this rollout is, proceeding across millions of machines or whatever it is. So we had a very, very easy model where a user could just say, hey, this is I know I would get this version, I would get version 10, I actually want version 9. And they can say, I want version 9, restart the job, they get 9. So it was, could take them minutes to switch and roll back. And one of the things we wanted to make sure is when they do that, is that we weren't letting that linger, right? So you don't want to let rollback stay in production forever. It needs to be a short-term fix only, short-term remediation. So we actually had a requirement that they had to file a bug with it, and they had to say what the bug was. We kept a dashboard of these, we could go through, we made sure that they were very, very short-term. And of course, we were very proactive about fixing them, right? So you want to make sure, okay, someone had rollback, let's fix it. And then, of course, if you actually see lots of people rolling back, you realize you have a real bug, you roll the whole thing back, you try again next time. Okay, so we got deployed, we got it upgrading. So what are the things we learned about during this process? So one of the biggest things is to invest in debugging tools, right? So there was actually already a talk this morning about debugging, but you want to make sure that it is very easy to figure out when there is a problem, right? So when you have something like a sidecar, you're now talking about 2 processes, sometimes 3 processes, where you used to be only talking about 1, and things get complicated, right? You got more moving parts, you have things talking to each other, you have to debug across process boundaries. Maybe you're debugging in different languages, right? Like maybe it's Java and the sidecar is C++, and it just gets really confusing and complicated. So you want to make sure that you have these debugging tools that let you really quickly know, okay, whose fault is it, right? What went wrong? How often is it happening? And there's the tooling part of that, and then there's also just the monitoring part. So you really want to make sure you're doing a lot of monitoring, checking for what's wrong and keeping dashboards of that. One other thing actually that we learned that really is probably irrelevant for most people, but for anyone that's going down the crazy path we went down, is that you want to make sure the communication channel between those processes is very, very solid. So we were actually experimenting with some shared memory transports that let us do sort of low single-digit microsecond communication switches between the sidecar and the application. It turned out building that yourself from scratch and then trying to roll it out was a bad idea. It was not as solid as we wanted. It actually had lots of bugs. Things broke all the time. We ended up just ditching that and switching to Unix domain sockets, and suddenly all those problems went away. So you really want to make sure that if you do something crazy, try to spend your time making sure it actually works really, really well. Because actually this kind of goes for anything at this scale. When you're talking about millions of processes, any little thing that happens very, very rarely still happens all the time, right? It's the usual lesson. The other thing I talked about before, you're going to take a performance hit. You have to know that and accept that up front, right? This is going to be a cost. If you are designing client libraries that you stick in a sidecar rather than proxying, which is mostly what this conference is about, more of the proxying, but for us it was actually more of the clients that were interesting. You want to make sure that you design that as a batch connection, not chatty, right? So we actually had a case at one point where we were sending every single log line output by the application was a single RPC to the sidecar. Actually, that worked pretty well for most services, and there were a couple that actually were just outputting huge amounts of logs, and it just completely broke them. So switch to batch, problem solved. And of course, always invest in performance, right? Never stop that. Another lesson we learned actually was around default behavior. So if you are going to change something, right, for millions of users, you should probably not just change it. You should probably do the exact same thing I was talking about with the rollouts, where you have some sort of opt-in, people can try it out, right? You do it over time, you get people used to it, and then you slowly change the default. And you warn them, all those lessons about how to do a rollout also applies to any change, really. Anything, and even when you think it's innocuous, it's not going to be innocuous, it's going to break someone. Any change is a dangerous change. You have to roll it out slowly. So we had very, very strict rules about guarding behavior. We had strict rules about adding new connections. A lot of these rules were put in place because of mistakes that we made. So we actually had a point where we broke one of Google's few billion user systems for several hours because we added a new connection. That new connection took out a backend system. That backend system was being relied on by a different system that didn't have any timeouts and cascading failure, and it took out huge swaths of Google. So don't do that. Make sure that you are not introducing new behavior without thinking it very, very, very carefully. Another actually interesting lesson, and some of this also applies to how we put together Istio, is try not to do anything too fancy, right? So there's some cool things you can do. You can do like hot restarts. You can try and like do updates in place and like all this kind of crazy stuff that sounds really cool on paper, but in actuality just makes things more complicated and harder to debug and harder to figure out what went wrong. So like, for example, one of the things we did was just, we said, all right, should we have the sidecar be able to restart? If it fails, should it be able to come back up? Or like, should it restart the application if the application goes down? Said, no, forget that, right? They're tied together. Let's just make the sidecar as bug-free as possible. Our goal at the time was like, no more crashes than the kernel. So the amount of times that the kernel was crashing, the sidecar was allowed to crash about that much too. And that level of sort of background crashing was acceptable. Most people wouldn't notice because their application was crashing way more than that. And what we did was anytime one of those crashed, the other crashed too. And they took each other out. And then they'd restart, and we used our internal system that's a precursor to Kubernetes for container management just to restart the whole thing, and everything was fine. So we didn't do any of the hot reloading. We picked up new things on restart, right? So we didn't roll out new versions dynamically. We just waited for things to restart. It turned out this worked well for us. There are probably people here who are running systems that don't restart that often. If you do that, then obviously you're gonna need to figure out a way to roll out your updates in a little bit different manner. Maybe you just go restart those things. We actually, for a while, designed a system that would go and we thought about designing a system that would go restart people's jobs for them. We called it the smotherer because it would smother them. But we ended up not actually needing that, right? Everything actually worked out without that, so we were okay. Another lesson here is around what I was talking about earlier about testing. So you want to make it really easy, both in dev and test, to try this thing out, right? Like the first experience with the sidecar for any of your of developers should not be in production, right? It should be local in testing. All your automated tests should run with it, right? Like everything should run with this thing. And so we made sure that was very, very easy, that the user experience was simple. It was like a one-line change to a build file, and everything just worked. Okay, so the last lesson, and the most important one, is that actually this is totally, totally worth it. So, I've actually worked at Google for a very long time, and I remember sort of prior to us having this, a couple different incidents where basically every engineer at Google had to go take some change to production for some fix. So we had a couple security-related ones. We had a couple other ones that were sort of top secret, so I can't really talk about the details. But there were these changes that like, okay, everyone needs to take this and get a build out and get in production by Friday. And it was like 20,000 engineers or whatever at the time. Everyone's got to go fix this thing, and that was really, really, really painful. And then after we had this sidecar in place, I remember a change where there was something basically similar that happened, but it was in one of these libraries we controlled, and we rolled it out in a week without breaking anything, without anyone noticing. And it was like, all right, we won, we did it. That was like worth it completely. That made up for the years of rollout it took us. It's completely, completely worth it when you do that. Okay, so that's all I wanted to go through. Anyone have any questions? I think I have like 5 minutes. Yeah, for any questions. So the question is, how do you roll out a sidecar where some have a sidecar and some don't, right, without breaking the communication? So I'm going to give you two answers. So for Google, actually, our sidecar was not originally for proxying of communication. It was mostly just a client library, so we didn't really have that problem. But actually, as part of Istio, we do have that problem. So for Istio, the way we designed it is to work that way. So you can actually add a sidecar to something, and the other side doesn't need a sidecar, and actually it'll keep working fine. You have to roll out the sidecar as a restart, so you're not going to like roll it out while the connections are still live. But yeah, it works perfectly fine to have sort of sidecars and non-sidecars. And one of the hard things there is actually around mutual TLS. So one of the things Istio supports is you can have what's called permissive mode, where both TLS and non-TLS can talk to the same port. And so you can actually have your new sidecars that pop up are going to be talking over TLS and they'll be encrypted. And the old ones that are not yet running the sidecar won't be, and it'll just continue working fine. Anyone else questions? Yeah.
I think you slightly alluded to this, but right now Istio is built in golang. Is that a more performant sidecar you're envisioning in C++?
So the question is about Istio and Golang and the sidecar. So the sidecar is actually Envoy, which is C++. Yeah. So and that actually was intentional. So when we were starting the Istio project, basically the first thing we were doing is looking at proxy implementations. So I had just come from building my own proxy internally that was super fast, but like could not be exported. It was really based in, it was like you'd have to export all of Google's technology to get the sidecar. So we were like, all right, what do we use? We were looking at Nginx, we were looking at HA proxy, and that was actually about the time that Envoy came out, and we're like, all right, it checks the box of C++, it checks the box of, well, it didn't quite check the box of performance at the time, it's gotten a lot better. But yeah, that was actually a big driver for us. We would not have chosen a Golang version of the sidecar.
I want to rephrase the question. I'm sorry.
Yeah.
The question is more on the Istio control plane component. The Envoy checks all the.
Yeah, so on the control plane and performance, so the main thing to worry about on the control plane is usually more scalability and resource usage than pure latency. Latency you care about in terms of like updates, so if you're getting an update in time, but you don't have it in the critical path, right? It's not in the data plan. So you're not actually paying a latency hit for, let's say, Istio's control plane taking an extra 2 milliseconds versus if it was written in C++. So there the focus was more on extensibility and ease of engineering and the other things that make actually Go a pretty good language. Yeah.
So how many sidecars do you usually have within a pod? And what are some of the more core functionality of the sidecars?
The ones we run at Google?
Yeah.
So we don't have pods, we have jobs, which are basically pods. They're very similar. Actually, Alex and pods are similar, I guess. So we actually talked a lot about this for a long time. We were talking about the like sidecar per node versus per process versus per whatever. And we came up with the same model that we do in Istio, which is basically per pod. So you end up with the sidecar per pod. And a lot of the reasons are actually the same as the reasons in Istio. So you avoid having to deal with a lot of security problems. If you tried to do a proxy per node and those nodes are multi-tenant, that's actually really difficult to get right and to guarantee that those things aren't able to interfere with each other. Even in a trusted environment, like most of your interference is actually accidental. So can, this person who randomly started up some job take me down? If you're running at the node level, you can actually take each other down pretty easily. So we put one per sidecar, and that actually also helped with the rollout, right? So if you're rolling out and you're controlling, and each, let's say, pod owner in the sort of cloud native model, right, can say which version they want, right? You can't get that at a node level, right? You can't do that same kind of version control. So it works really well to have it per pod. The downside is resource usage, so you have to make sure that you're lightweight. Yeah, cool. All right, thank you, everyone.